Good afternoon. I'm Spot On Weather meteorologist Matthew Euler. And today we're going to take a look at the snow factors for Hampton Roads. All right, and this is a very interesting presentation. We're going to go into the many factors as to why Hampton Roads does not get more snow in the wintertime. So let's take a look at that. So Hampton Roads does not get more snow, and these are the factors that are responsible for that. First of all, we have the Appalachian Mountains, which are situated to the west. I'm going to get into that here in a moment, the effects of mountains to the west. We have a modifying effect of the nearby Atlantic Ocean waters. Third, storm tracks pretty much have to be perfect. What I mean by that is the storm tracks cannot be too close to the coast, yet not too far off the coast either. Fourth, storms must not be too strong. If that's the case, then you increase the low-level wind field and the winds that pick up and then they blow warmer air off the ocean. And then fifth, typically the coldest air does not arrive until after the coastal storms are well out to sea. All right, so first thing we're going to take a look at is the Appalachian Mountains to the west. What happens as, you might be viewing a radar image of the United States in the wintertime, and you may see this big area of snow, basically over Tennessee and Kentucky. It looks like it's heading east, and it's about the same latitude as Hampton Roads in Southeast Virginia, Kentucky and Tennessee. But yet, as that area of snow hits up against the Appalachian Mountains to the west of us, typically what happens is, as air rises, as that area of moisture and snow and that strong west or northwest wind hits up against the Appalachian Mountains, the air is forced to rise even further. Clouds form on the windward side of the mountains and they precipitate out. So you lose all the snow and all that moisture that you saw on the radar image, let's say back in Kentucky and Tennessee, and it falls out of the clouds on the windward side of the Appalachian Mountains, typically into the ski resort areas of West Virginia, such as Beckley. And then as the air goes up and all the precip comes out of the clouds, and as the air basically sinks down the other side of the mountain, we get what is known as a rain shadow effect, where there's no more moisture. So the air becomes much drier as it descends the eastern side of the Appalachian Mountains, and by the time that air arrives here in Hampton Roads, it is much too dry to produce any type of snow. It's usually just a very cold west to northwest wind by that point. So that is one of the factors as to why we don't get as much snow here in Hampton Roads in the wintertime, the mountain range in the Appalachians to the west. The second factor I want to talk about is, and this is a very important factor, is the modifying effect of the water. Overall, coastal locations tend to be milder than inland locations due to the specific heat capacity of water. Water pretty much does not cool down as rapidly as land. As far as dry air, continental air, that generally warms and cools 3 times faster than maritime air or air closer to the water. What does this do on the effects? I'm going to get into that here in a minute with discussion on the elevated warm layer. But the rain-snow line tends to form or set up from Hampton to Newport News for most winter storms as marine layer air gets entrained into the storm. And then you typically have more of a cold rain for Norfolk, Virginia Beach in most cases. All snow tends to fall from a line basically from Williamsburg northwestward to Richmond because they are further away from the marine influences of the water. So let's take a look at the sea surface temperatures in winter typically. And I want you to pay attention. Well, this is the scale on the right. We do have a very important feature that sits off the coast, and that is known as the Gulf Stream current. And with the Gulf Stream current, it brings much warmer water temperatures just off the coast northeastward. So you have a strong temperature gradient of the ocean waters just offshore of Southeast Virginia, which is right here. So what happens is, if you get areas of low pressure that come in off the southeast coast, the counterclockwise circulation around these low pressure systems tends to bring or drag, the wind will blow over the warmer waters and it'll tend to bring milder air into storm systems. And when that happens, that tends to result in an elevated warm layer developing aloft above the surface. And that will generally erode any cold air that may have been in place at the surface, resulting in melting snowflakes and raindrops reaching the surface for most coastal locations in Southeast Virginia. Here is the elevated warm layer. The left image here is courtesy of the Weather Prediction website. So what you have is generally a below freezing layer, which is way high up in the atmosphere. And then right below that below freezing layer, you have what's known as an elevated warm layer. And this elevated warm layer may be 5,000 to 8,000 feet above the ground. And what happens is, as the wind blows in off the warmer waters just to the southeast of Virginia, off the warmer Gulf Stream, that tends to increase the depth of the elevated warm layer, the above freezing location aloft. And what happens is, as snow starts to fall from the base of a cloud below freezing level, as it falls into this above freezing level, the elevated warm layer, it tends to melt. And this layer over time gets thicker and thicker to where it expands, and you get mainly a rain event for the coastal locations across Southeast Virginia. On the right here shows you a temperature profile. This line right here is a temperature profile line. Here is the 0 degree line vertically downward. And when the line goes to the right of the 0 degree line, that indicates a elevated warm layer aloft. And that's going to result in melting of snowflakes. It's typically the case of what happens, again, as the wind blows in off the warmer waters of the western Atlantic Ocean from the Gulf Stream. All right, and then storm tracks are equally critical. This is a case of the January 22nd to 24th, 2016 mid-Atlantic winter storm, where you had some locations just outside of D.C. into northern Virginia where they got 2 feet to just over 2 feet of snow. Look at the location of the center of the low pressure system. It's situated almost right over the top of Virginia Beach at this time. This is a case where the low track is too close to the coast, and as this thing gets wound up, the counterclockwise winds around this low will tend to bring in milder marine layer air. So in this case, we got a heavy 2-inch to 3-inch rain, cold rain over Southeast Virginia, while if you drove about 100 miles inland, Richmond up towards D.C., especially Northern Virginia, you would have had a blizzard on your hands. So this is a case where the low pressure system is too close to the coast. You can see where the heaviest snows occurred with this storm well to the northwest of Southeast Virginia. We got a little bit of a dusting at the initial onset of the storm with the cold air in place, but ultimately the track of this storm system was too close to the coast and resulted in the majority of precip falling as rain. On the other hand, here's a case study from last year in January of 2017 where we got a pretty good snow here in Southeast Virginia all the way down to the coast, where typically the average was about 6 inches of snow. The storm track, the area of low pressure, is a little further to the southeast and offshore, and what that did is it does not allow this milder air from the winds blowing in off the warmer waters to get into the storm very much, and that results in cold air most of the storm system. Cold air will be in place, and precip falling mostly in the form of either sleet or snow. So this happened last year. I want you also to notice that there was a cold high pressure system to the north, which funneled in cold air continuously throughout the storm. We actually had a blizzard warning for Virginia Beach last January during this particular event. And that blue dash line, which is basically back to the west, that is your freezing line on the surface. And then this was the December 2010 big winter storm system. Again, notice where the center of the low is. It's to the southeast of Cape Hatteras. It's offshore and it does not come on shore. Also, we have this jet stream and area of vorticity where air tends to rise along these yellow colored areas. We had a deep trough of upper level low pressure over the eastern U.S. at the time, a cold pocket of air in association with a low pressure system at the surface that tended to remain well offshore. It was not right on shore. It remained well offshore, The warm sector of the storm stayed offshore with strong southeast winds, but it was not allowed to push all the way in to southeast Virginia, which resulted in 12 inches of snow in most locations between Chesapeake and Virginia Beach. This was the December 26th Christmas. It started Christmas night in December of 2010. And quite a storm for the area, actually. And then lastly, another factor we talk about is when cold air arrives too late in many cases. So typically in the backside of these storm systems, you get much drier, colder air. It's known as the dry and the cold conveyor belt. And what that does is air tends to sink and the air column dries out rather rapidly behind these departing low pressure systems on northwesterly winds. Well, a lot of cases you'll have rain initially in place across southeast Virginia, and then by the time the cold air actually pushes in from the northwest, this storm system is well out to sea, and most of the dynamics that you need for lifting and forming the clouds and precipitation are well off away from the coast with drier, colder air building in. So basically you have cold northwesterly winds which dry the air column out from the ground to about 18,000 feet behind departing storm systems as high pressure builds in from the Ohio Valley. That happens quite a bit for southeast Virginia, actually. So there are many factors to consider. You look at the many factors to consider as to why Hampton Roads does not receive more snow in the wintertime. Average snow for Norfolk, for example, is only 7 inches in a winter, a typical winter. And these are the main factors. The mountains to the west tend to produce a rain shadow effect, where most of the snow falls on the windward side into the ski resort areas of West Virginia. As air sinks down the east side of the slopes, it tends to dry out by the time it reaches Hampton Roads. The modifying effect of the water, I can't state that enough. It's very important to look at the water temperatures in the area to determine if we are in fact cold enough to get snow. And that can be very critical. We've had some winters where the water temperatures right off the coast are much colder than other winters. And the Gulf Stream current, again, is a very important current off the East Coast, showing how the temperatures, there's a large temperature gradient across these ocean waters right offshore. And then again, the elevated warm layer and how that elevated warm layer tends to thicken up over time as winds blow in off the warm water. Here's a case of storm tracks being critical. Again, they cannot be too far off the coast or too close to the coast. It has to be right in that perfect location, such as this spot in what happened here on this track in December of 2010. This is where you can find us on Spot On Weather. I hope you've enjoyed this presentation. We're on Facebook. We're on Instagram. We are on Twitter. And we also have a website where I do blogs occasionally. Click the news tab at the top, spotonweatherweebly.com. All right, that's all I have for now at Spot On Weather. I hope you enjoyed this presentation. Have a great Monday, everybody.